We're still talking about circles in Chapter 10, so Lesson 10.2 is about arc measures. A central angle of a circle is an angle whose vertex is the center of the circle. So in this particular case, angle ACB is a central angle of circle C, since the vertex of that angle is the center of the circle. Since the measure of angle ACB is less than 180 degrees, all the points on the circle that lie in the interior of the angle form what is called a minor arc, which is named arc AB. Notice that what we draw across the endpoints is a small arc to represent minor arc AB. The points on the circle that are not part of the minor arc form what's called a major arc, which is named arc ADB. Notice that for a minor arc, I just need to use the two endpoints. If I see that, I know that I am going the shortest distance from A to B. But for my major arc, I can't just put AB because you would think I was talking the minor arc, so I have to give you a point that I'm going through. So that's the reason we name a major arc with 3 letters. A central angle formed by a diameter, which is a straight angle, forms an arc known as a semicircle. RS is the diameter of P, therefore arc RS is a semicircle. Now, you wouldn't know which direction to go, so that really counts for both of those. So if I wanted you to take one particular route, I would have to use 3 letters to name the semicircle that I wanted to pinpoint. The measure of a minor arc is the measurement of the central angle. So if a central angle has a measurement of 30 degrees, we say that the measurement of the minor arc is also 30 degrees. So the expression, the measure of arc AB, you can see the measure of an entire circle is 360 degrees. And the measure of a major arc then is the difference between 360 degrees and the measure of the related minor arc. The measure of a semicircle, since it would be half of the circle, is 180 degrees. So in this case, the measure of arc AB is 50, and the measure of arc ADB then would be 310, or 360 minus 50. So find the measurement of each arc of P where RT is a diameter. So first we'll look at arc RS. So since there's only 2 letters, I'm going from R around to S. Remember, the arc is the same as the central angle. Therefore, arc RS has a measurement that is 110 degrees. For RTS, to go from R through T around to S, I'll change colors here. Let's go with the blue. From R through T around to S. Well, I'm going to find that by taking the entire 360 and subtracting away the 110, so we see that it is 250 degrees. The arc RST. Now notice I used 3 letters to show you which half of this I wanted you to take. But since RT is a diameter, RST is a semicircle, and therefore it's 180 degrees. 2 arcs of the same circle are adjacent if they share an endpoint. We have a postulate, just like we had a segment addition postulate, we had an angle addition postulate, we have an arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of those 2. So if I want to go from A to B to C, I could either find the measure AC and subtract from 360, or if I know the measure AB, arc AB, and arc BC, I could simply add those 2 together. A recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or some other famous person, and the results are shown below. So what is the measurement of arc AC? From A to C, going from A to C is made up of arc AB and BC, so I can simply add those two together and get that the measure of arc AC is 137 degrees. Measure ACD. So I'm wanting to start at A, go to C, all the way to D. So I could add up those three, or I already know AC is 137, so I could just add the 83 to it. That's probably the easiest way to do it, and we see that it's 220 degrees. To find ADC. So this time I'm wanting to start at A. Let's pick up a green. Start at A, go through D around to C. So from A through D around to C. Well, I already know that AC is 137, and that's the rest of the circle, so I can just do 360 minus that 137, and it's 223 degrees. And last, they want EBD, so from E all the way around through B, back to D, and that is all except this 61 degrees, so 360 minus ED gives me 299 degrees. So here's some for you to try. You should pause the video and give them a try, and then we'll check the answers and discuss it. TQ. TQ is a minor arc, so since the central angle is 120 degrees, then the measure of the arc is 120 degrees. QRT. QRT is a major arc, and its related minor arc was TQ. So what we're doing is we're looking at going back around this direction, and so it's simply the 360 minus 120 gives me 240. TQR. For TQR, we can add those two together or notice it as a diameter. So it is a semicircle, 180 degrees. QS, to go from Q to S, is everything except this part from S here. So the shortest way from Q to S, remember, is not this way. I would have to say T, because this is less than 180. So I could figure out that 120 plus 80 is 200, and so the arc is 160. TS, well, we can see that its central angle is 80, so it's just 80. And RST. RST is 180 degrees because it's a semicircle. Congruent circles and arcs. Two circles are congruent circles if they have the same radius. Two arcs are congruent arcs if they have the same measure and they're either arcs of the same circle or congruent circles. You can write that two circles are congruent symbolically. So let's look at this one. Tell whether the red arcs are congruent. Explain why or why not. Since they both have a central angle of 80, we know that they have the same measure, and since they're part of the same circle, then we know that they are congruent. In this one, they both have a measure of 90 degrees, but they're not part of congruent circles nor the same circle, therefore they are not congruent to one another. And in this one, it looks like our radii are marked to be congruent, and they have the same arc measurement, therefore they are congruent to one another. So tell whether the red arcs are congruent, explain why or why not. In this case, the radii are marked to be congruent, the angles have the same measure, so yes, they are congruent. In number 8, we notice that they both measure 120 degrees. However, the radii are not congruent, so they're not from congruent circles. We cannot say that those two arcs are congruent.